In this tutorial, we'll go through sample image generation, file name-based calibration, and the close button. Run ImageJ with custom macros installed. Remember, if you need help with procedures or a quick list of shortcuts, press the Help button. Log in by pressing the Start button. Since we're simply exploring functionality rather than running an experimental analysis, log in as default. Press keyboard shortcut V to create the standard sample image. To customize a sample image, press Shift V. Let's create a sample image with the following parameters. Pressing V again automatically creates that customized sample image. The standard ImageJ Close All menu button prompts users to save images. It also only closes images, not text or function windows. Instead, press the custom macros Close button to close all windows. Let's now explore custom macros file name-based calibration system. Press Shift V to create the following sample image. Note that we set the calibration multiplier here to 20x. This part gets a little technical, so please follow along with the text on the screen. Press keyboard shortcut F11 to open the info window. So the calibration multiplier is a 1 to 4 digit number preceded by a space and followed by an X, and then another space or a period. So in this case, the calibration multiplier of 20x is bound by 2 spaces. So for example, the calibration multiplier for the file Archaeopteryx19 tmaze space 20x space snc section 12.tiff is 20, just as it is 20 in Archaeopteryx19 tmaze snc section 12 space 20x.tiff. What this means is that there's no bounding space here, just a period, but the calibration multiplier is read as the same. So the calibration multiplier is intended to correspond to the magnification at which an image was taken. The resulting unit squared, so that's typically micron squared for microscopy, so that's unit squared per pixel calibration, is calculated based on the technical specifications of your camera's sensor chip. So our camera's sensor chip has a value of 6.45 microns squared. And this sensor value is the base calibration that you see in the info window. Now, base calibration can be easily adjusted to match your microscope's camera by editing a file called calibration.ijm in the custom macros folder. And please see documentation for details. So scale, which is used for measurement results, is set by dividing the base calibration by the calibration multiplier or magnification. So for example, a base calibration of 6.45 microns squared divided by a calibration multiplier of 20 would equal a scale of 0.3225 microns squared per pixel, which is indeed what you're seeing in the info window for our image. And finally, note that calibration multipliers can be very useful independent of actual camera settings as a way of scaling images as needed. see documentation on the scaling tool, which is invoked by keyboard shortcut K, for details. So let's see what Filename-based calibration actually accomplishes. Press Shift plus V to create the same sample image, but this time with a 10x calibration multiplier. Select the 20x image and measure it using the ImageJ menu command, or measure command in the menu. And that's also shortcut Control plus M. And now do the same for the 10x image. So let's take a look at the results. Note that while mean, mode, and area fraction and other distribution-based measurements remain constant regardless of calibration, the area and integrated density are 4 times as large between 10x and 20x. Press Shift V one last time to create an image with a calibration multiplier of 0x. Now what this calibration multiplier is telling ImageJ to basically do is to not scale the image, but just treat the scale per pixel. And let's measure this image. So let's compare. In this case, the area of stripes 0x is 90,000, which is 300 times 300 pixels. And finally, the raw integrated density is the same as the integrated density, meaning there is no scaling per pixel. And there you have it. That is Filename-based calibration, and that's how you would scale measurements in custom macros.